Hello and welcome to Noel's Retro Lab. It's time to go back to the Amstrad PPC loggable and continue looking for a good way to replace the LCD with a modern one like we saw last time. We already saw a couple promising options, so today we're going to look at one more option, pick the one that works best, and install it in the Amstrad in a more permanent way. As a quick recap, and if you haven't seen that video, I recommend you do that now. All the options revolved around replacing the LCD with a modern VGA one of the same size and converting the external CGA video signal into something the LCD can use. The first option we looked at was MCE to VGA, which worked great out of the box with all sorts of bells and whistles, but it was a bit pricey. The next option was the GBS 8200 board, which has been around the block for a few times. It had some issues with the stability of the image, but that might have been just my fault for not combining the sync signals properly and using some capacitors. This option was not very expensive and all the problems could be worked around, but the big drawback was fitting it inside the case, so I didn't take it any further. Before we start with option 3, I received several comments saying that the GBS 8200 would actually fit in the case if I removed a few of the connectors. So maybe I was a little too quick dismissing it. So in other words, will this fit in here? So let's open it up and see if it would really fit in there or not. So yeah, you see the board sticks out into that slot. Now, this doesn't fit like this. This is what I saw last time. There are those pegs in here and there's the board in here. If we did remove those two connectors, would this fit in here? So, or maybe in other words, like this. And you know what? I think those of you who said that, you were right. And it would actually fit perfectly if it wasn't because of those tabs in there, that plastic, those pegs. So if we wanted to make this permanent, it would actually be probably ideal to file those down just a little bit, and then the board would fit straight in there. Okay, I'm willing to put this back on the table as a possibility. Option 3 is using the RGBtoHDMI project. That's an open source project that uses a Raspberry Pi Zero and a small CPLD to process the video signal and generate an HDMI image through the built-in Raspberry Pi video output. This kind of approach is only now becoming possible because the Raspberry Pi Zero has some pretty impressive specs and it's able to sample the input video signal in real time. Additionally, the Raspberry Pi Zero has a very small footprint and the RGBtoHDMI board fits right on top, so it should fit very nicely inside the Amstrad PPC case. As a bonus, this same project can be applied not just to CGA video signals, but to a huge variety of computers, from BBC Micros to even Amigas. The list is huge, so this is something you may want to keep an eye out even if you're not working specifically on a CGA PC. When I started preparing this video, the RGBtoHDMI board wasn't available for purchase anywhere. But since it's an open source project, I thought what anybody would think, and that's PCB way! Which, by the way, are the generous sponsors of this episode. But sponsoring aside, it's really awesome to be able to download the Gerbers from GitHub, upload them to PCBWay, click on order, and a few days later, bing, there you go. One ordering tip for you, and hopefully this doesn't invalidate my sponsorship. Normally, the minimum order for PCBs is 5, but when they're this small, you often get 10 for the exact same price, so make sure to check that before you complete the order. The rest of the components are pretty minimal, and they're really well explained in the bill of materials on the project page. It mostly comes down to a CPLD, which is about €4, and a smattering of passive components that you may already have lying around in your lab. So let's go ahead and assemble it. The CPLD might be a bit challenging, but hey, it wouldn't be fun otherwise. So as usual, we'll start by wiping the board down with some alcohol. This is brand new, printed from PCBWay, but you might as well, just in case there are any grease, any fingerprints that I accidentally touched it with. And then we'll start with the smallest, the shallowest component. So that would be the CPLD and the SMD components. And it turns out the CPLD was pretty challenging. It started out bad from the start when I failed to align it properly. In my defense, I'll say that doing this with a camera in between you and the workbench makes it about 10 times more difficult. I'm actually leaving all of this in the video so you can see that even when soldering something like this goes horribly wrong, you can usually fix it with a bit of patience. So don't give up if something doesn't start out perfectly. Anyway, after I managed to align it properly, then I tried to use the drag soldering technique, and maybe it's because the legs are rather small or because I'm using too thin of a tip, but it just didn't work at all. Instead, I got big blobs of solder shorting everything. But again, it's okay. I can use a weaken braid and remove those blobs. And now that things are a little bit better, I'll make another pass and get the soldering even. That looks a lot better, doesn't it? And just to make sure, I'll examine it under the microscope. And it seems to be fine. I noticed that some of the pins didn't have much solder in them, so I can add some now, but other than that, it looks very reasonable. The rest of the components are a breeze in comparison, so sit down and enjoy the chiptunes. We'll finish this in a jiffy. Don't I wish it were like this in real life? Okay, that looks pretty good. And now we only have left a few large components, so I'm switching the soldering iron tip, and let's do those. Okay, and all we have left is the header right there. Actually, on this side. Can't forget that. It turns out that right here we need 2 resistor arrays, and for whatever reason, I completely missed them when I placed the order for the components. So what I ended up doing is I found out exactly what configuration those resistors are in the array, and I made my own. So these are 5 4.7k ohm resistors configured this way, with ground here and each of them going to ground. So I made 2 of those, and we'll just put them here. It shouldn't matter that they're individual ones instead of being in a pre-made pack. Okay, all done. We just need to connect it to the Raspberry Pi, and that's it. Before even connecting it to the Amstrad, let's turn it on and prepare it. Okay, we get a menu, and it detects that the CPLD isn't programmed, and it gives us the option to do that. So I select the 6 to 12-bit CPLD, and it brings us back to the same menu. And now it says that the CPLD is unknown. That doesn't look right. I wonder if I soldered the CPLD correctly. I have to admit, I only did a visual inspection, and I didn't check for shorts pin by pin as I should have done. Okay, time to dig out the microscope again. And yeah, check it out. We have a short right there. And it's crazy, you can't see much visually. Just a hint that there may be some solder in between the legs closer to the body. The easiest way to fix that is usually to add some flux, or lots of flux in this case, and heat it up with the iron. With any luck, the solder just snaps back towards the legs and it fixes the short. But not in this case. I can see it there, but I'll check anyway. Yeah, still there. Okay, so plan B. Add even more solder, create a bigger short, and then use the weaken braid to remove it all. That removes a bit too much, so I'll just make a pass to freshen it up and add a little bit more solder. There you go, perfect. I'll spare you the rest, but I went pin by pin and I found a second short in a different side and fixed it in the same way. And now when I power it on, great. It looks like it recognizes the CPLD and just shows us the regular menu since it doesn't detect any input signal. Now it's time to connect it to the computer. I'm going to build a quick adapter to connect it to the 9-pin CGI cable. Normally this is prepared to hook up some pin headers, 90-degree pin headers, and that would make it easier to plug and unplug different signals if you're going to be using this in different computers. I also forgot to get that 90-degree double 90-degree pin header, so I'm just going to solder these cables directly here. I guess I should have made this a little longer. I expected this to come out this side. I was not thinking about the resistor packs. Oops. Yeah, it looks like it's fine. There's nothing that can be shorted there, and the cables just go straight through. So yeah, I was trying to keep it as short as possible to avoid any kind of interference. So this is kind of compact. Okay, time to test it. So I have the RGBtoHDMI board here already and already powered. So I've connected it to the CGA external output of the Amstrad PPC with an HDMI cable to the driver board to the LCD we saw last time. So yeah, I'm just gonna turn it on and let's see what happens. Nothing so far. Oh, okay. All right, so mixed results. So there's a couple great things. Obviously, we are seeing something, so that's really good. The flashing, I don't know why it's doing that. And also, I was afraid that this board was going to default to VGA input all the time and that we were going to have to swap it, but it detected that it's connected to HDMI and switched to that. So that's great. I accessed the menu and I tweaked a few settings to get rid of the flickering and adjust the screen geometry. Okay, now I really got it to a nice layout. We can see both the end over here and the bottom, the top and everything. And what I saw is that we can also save configuration. There you go, saved as cga.txt. So hopefully whenever we turn on the computer again, it will have this particular configuration. So let's try loading it again with it, see how that works. Okay, that's great. Look how it fits perfectly. I was afraid that maybe the geometry would affect the text screen in MS-DOS, but not when it switches to a graphical mode. But this is great. There we go. Looking at the different options, I found something very useful, or that I like, which is the power up message, that little text that puts up when you first turn it on. I didn't like it. I mean, it's informative, but it breaks the illusion that this is really the original computer. And you can turn it off like I did right there. And if you save this and you restart the computer, if you turn everything on, you get a flash, but you don't get any of that text. And I believe the first text that we get should be MS-DOS booting up. There we go. Blinking cursor, beeping, and now we get those messages. So that's perfect. So how about the cost of the setup with this option? The LCD is still the same as before, but we'll need to buy a Raspberry Pi Zero, which can be had for as little as €7 shipped. As for the RGBtoHDMI board, when Ian, the creator of the project, was selling them directly, they were going for about 30 shipped and you had to do some assembly, so the total was about €65. That's pretty good when compared to the €120 of the MCE to VGA approach, but a bit more expensive than the GBS 8200 option. However, here it's possible to lower the costs significantly if you're willing to put in some work. You can make 10 of these boards from PCBWay for about €14 shipped. The components themselves are really cheap except for the CPLD, which goes for about €3.50, so all in all the components are maybe €5, and that brings the total down to €41, which is even slightly cheaper than the GBS approach. To me, the clear winner is the RGBtoHDMI project. It's inexpensive, the quality is great, and is very configurable. I'm sure you can get it to do monochrome modes as well if you wanted to. The only weird thing when using a microprocessor like this to enhance an older computer is realizing that you're adding a significantly more powerful computer than the original computer itself. But if you get past that, it's actually a great solution. Let's see how we can fit everything back inside of the case in a more permanent way. So the LCD obviously has to go in the frame of the existing screen, so that's fine. It fits in there, that's not a problem. What we need to decide is where we're going to put the LCD driver board and the RGBtoHDMI plus Raspberry Pi boards. We have multiple options. We can use the area of the modem. We can use the area of the battery, because I'm not planning on putting those big batteries in there. And we can also use the extra space in the screen frame, because there's definitely a lot of room behind the LCD itself. The frame is pretty thick. The RGBtoHDMI board plus Raspberry Pi, it's out of the question here, unless we change the configuration to open it up, which is totally possible, but as it stands, this is just too big to fit here, plus the LCD, so that's out. You may be tempted to put the LCD here and have the ribbon cable come out, but it doesn't quite work so well. First of all, the original ribbon cable came from the side, so this is actually kind of difficult to fit it there because it doesn't really bend, so it's kind of messy. And then we don't have that much cable left. So I think a better option is to try to fit the LCD board in here and the LCD screen on top. Now, it almost fits, but not quite. There are a few things that stick out, but we don't need those things. We don't need the VGA connector, we don't need this connector, so we can remove those and actually lower this enough that I think this and the LCD will fit very snugly there. All right, that's much better. The thing sticking out the most right now are those two capacitors, so I think I'm just going to replace that one with a smaller one with the same values, and that should lower that quite a bit. So now this fits perfectly fine in here. The LCD fits on top, and I think it's just the right, there we go. This is like, I almost don't need anything else, and this is perfect. But just the LCD present in this is a little precarious. So I think what I'm gonna try to do is use this kind of foam and make a cutout. So this fits exactly in the middle, and this provides even more padding and more friction so the LCD doesn't move. And then I also need to remember to make some room for the cables to come out. So I cut the foam to fit the frame, and now we need to figure out where we're gonna place the driver. So the constraints that we have are that the cables need to come in through here, and that one of the cables it's an HDMI cable that is rather big. So I can't have it any closer than this. So that looks about right. There's still plenty of play for the ribbon cable. So yeah, I think I'm going to mark this spot right here and make a hole for the board to fit in. We need to protect the back of the screen from shorting something here. So what I'm gonna do is I'm gonna cut up some plastic sheet that I have here and just lay it over, and this is pretty sturdy, so that should be plenty to separate the two and prevent any shorts. There's one more thing we need to remember, which is to remove the protective plastic that we've had here all along. This is very nice and sturdy. So I'm gonna screw it in. There we go, perfect.
And now we put the LCD back in the case. We need to get the HDMI cable through, and we need to solder the power cable to an appropriate point in the board.
So I realized that my plan of putting the RGBtoHDMI boards here, maybe it's not such a great idea. It doesn't fit as well as I was hoping for. It has this ridge down the middle. And then I would have to punch several holes to get all the cables. Remember, we need to get the CGA cable, the HDMI cable, and the power cable. And if there is another way that I can avoid making permanent modifications to the case, I will. So I think I'm going to use a different solution instead. So I think I'm going to go with the modem area for the board instead. There's a lot more room. Actually, there's barely enough clearance. I think there's enough clearance, but I have the cable that I got was too long, so I can coil it in here, whereas it would be challenging on the battery compartment. And I'm not making any permanent modifications. So if later I find a different solution, I wouldn't regret punching some holes in the case. So this is fine. For power, I'm going to connect it to just 5-volt rail and ground right there in that capacitor, just because they're nearby. And one thing I didn't mention before is I'm trying to make it so this board can be removed. So I want to have connectors there. I don't want to solder anything directly here, because this is most likely something that I might want to remove at some point and come put back in. So that's why I'm using part of a USB cable for this. So the last cable that I needed is the CGA cable that I'm routing under the boards, or over, since we're looking at it from the bottom, over to the RGBtoHDMI, and now I just need to solder the right cable in the right place right there. Okay, I soldered in only the signals that actually carry any information for a CGA connector, and just so it doesn't move too much, I'll just put this here. And so it's all assembled. It's time to close the case and try it out.
That looks great. And yeah, it uses up the full screen, the correct aspect ratio. This is awesome. And there we have Prince of Persia again. Yeah, so much better than the original screen. Oh, hang on a second. This looks a little dark. The prince doesn't look quite right. Let's run a color test pattern. And oh no, that's why it looked off. CGA is supposed to have 16 total colors because we have 3 bits, which are 8 colors, and then 1 more bit for the intensity. So we're supposed to have a brighter version of each of those colors. And here we only see 8 colors. Okay, something is not right. So the first thing I just want to check is that the intensity signal is getting all the way to the correct place in the RGB to HDMI board. I'm going to put a pin right here and then check for continuity all the way here. That will take into account this solder joint, the connection, the cable, everything really. So that should be from here all the way to green 2. There we go. Okay, so the connection is good. I checked the schematics and the green 2 signal is supposed to go to pin 36 on the CPLD. So I want to make sure that that one is working. Yep, okay. So really the signal is getting all the way there. I want to rule out that the color problem is with the LCD. So I'm going to unplug the internal LCD and plug in the external monitor. Okay, so we still get the same thing. That means it's not our LCD. The problem is with the conversion from CGA to HDMI. So that's really good to know. So I checked and double checked and triple checked and I couldn't find anything wrong with it. So what I did is I built a new board. Same components, same everything. I even left the same Raspberry Pi and the same SD card. And that way we'll know if there was something wrong about this one. I mean, it's possible that the CPLD was damaged when I power it on with those couple of shorts. So anyway, let's go ahead and try it. This is all hooked up. Oh, and there we go. We see the 2 shades, the intensity bit and the regular color. And this is cool. I was wondering about this, but yeah, it does handle the brown color correctly. You need to do some special things to handle it. If you just convert the bits, you end up with like a dark yellow, but this is supposed to be brown. So that's great that the profile takes care of that automatically. And actually, before we put everything back in the case, there's one last thing I would like to try. I was just seeing Jan Bida doing a similar project with an Amiga and the RGB to HDMI board, and he had a single button coming out of the case to control the menu. And that would be awesome to have because right now the worst thing about this is that this is very inconvenient. Every time I want to mess with the menu, I pretty much need to open up the whole computer. And so I thought, wow, wouldn't it be great to make a hole somewhere? But you know, I hate making holes just to get a button out. And then I realized, wait, we already have a hole and we already have a button. We have this. And as far as I know, the only purpose of this, it's to beep at you if you close the computer while the power is on. And you know, maybe that makes sense if you're running again on those batteries or something, but I don't think that's a feature that I care about, but I would really love to control the menu there through this button. So let's go ahead and try doing that. Okay, so I removed the cable from where it went to on the board and just attached it directly to the first switch. So if all goes correctly now, I can press it and there we go. We get the main menu. So now we'll be able to control it from the outside without opening up the case. So let's reassemble everything and let's give it a try. Okay, let's see those colors. Perfect. Finally, we get the right colors, the right ratio. Everything looks really good. Let's see our menu. Can I go in the menu? I need to press it and hold it. There we go. I think now a click moves forward. And if I press it and hold it, it selects that. So great. And I believe that if I do a single click, it takes a screenshot. Yep. So that's also a useful feature to have. So this is really cool. Yeah, the colors look a lot better. There you go. Now it really looks like it should and not very dark like it did before. And for some more color testing, Paku is one of the great ones for testing that. It uses all 16 colors of the CGA at the same time. And the way it does that is it uses text mode, even though it doesn't look to be in text mode. And yeah, this looks fantastic. I'd say we have definitely met the goal of improving the original LCD's image quality. I know that some of you may feel that this is going a bit too far from the original feel of the Amstrad PPC, and you're not wrong at all. I'm usually not one to heavily modify original hardware,
but I felt the image quality of the original was so bad that it was worth taking this step. We're not done with the Amstrad PPC yet. I still have several episodes planned with upgrades that are going to continue improving this little machine and making it much more usable. Anyway, I hope you enjoyed this episode. If so, please give it a thumbs up and subscribe to the channel. As always, please leave your comments below and see you next time. If you enjoyed this video, please consider supporting Noel's Retro Lab on Patreon or joining the membership on YouTube. Not only is that the best way to support this channel and allow me to continue making more videos, but you also get some extra perks like early access, ad-free videos, and more. Thank you again to all the supporters. See you next time.